This is an example on solving a radical equation and checking for extraneous solutions. First, let's make sure we understand the vocabulary. As far as a radical equation is concerned, a radical equation is an equation with a variable in the radicand or raised to a rational exponent. Also, make sure we understand extraneous solution. An extraneous solution is a solution derived from the equation that does not make the original equation true. So we're about to see an example. Make sure we know it's a radical equation, and then after we solve it, we're going to have to check for extraneous solutions. We start out with the square root of x minus 3 plus 5 equals x. What I'm going to do to start out with is I have to get the radical by itself, and so I'm going to subtract 5 on both sides to leave me with the square root of x minus 3 equals x minus 5. At that point, what we've already learned, to get rid of a radical, this is a square root. To get rid of a square root, I have to square both sides. So I'm going to square this side, go over to the right side and square it. What that's going to do is make the square root and the square cancel each other out, leaving me with the base x minus 3 equals x minus 5 squared. I'm going to rewrite x minus 5 as x minus 5 times x minus 5. A lot of times we make a simple mistake of saying x squared minus 25, where we squared the x and we squared the 5. This is incorrect. Make sure we don't do that. At this point, what I'm going to do is FOIL this side. Let's take a look at and remember what FOIL is. FOIL is multiplying the first, outer, inner, and last. So my first is going to be the x times x, which is x squared. Outer, which is x times negative 5, which is negative 5x. Inner, which is negative 5 times x, which is negative 5x. And then last, negative 5 times negative 5, which a negative times a negative is a positive. So I'm left with x squared minus 5x minus 5x plus 25 equals, don't forget this side over here, x minus 3. Move our page down. Now on the right side, I can see that I have a couple like terms that I can combine, leaving me with x minus 3 equals x squared minus 10x plus 25. Now I'm still trying, I have to remember, I'm still trying to solve for x. And so what I'm going to do is I'm going to get these terms, x and the negative 3, and I'm going to get them over here so I can set something equal to 0. And that'll make solving it a whole lot easier. And so I'm going to add 3 to both sides, and I'm going to subtract x at the same step from both sides, leaving me with 0 equals x squared minus 11x plus 28. From there, I have a couple different options to solve this quadratic. I can complete the square, I can put it in the quadratic formula, or the way I'm going to solve it is by factoring. This right side factors into x minus 7 and x minus 4. I know that, and I can check my work to make sure I'm correct. X times x is x squared. X times negative 4 is negative 4x. Negative 7 times x is negative 7x. Negative 7 times negative 4 is positive 28. This will leave me with x squared minus 11x plus 28. So I know that I got what I started with, so my factoring is correct. So what I'm going to do is erase all this work that I checked to make sure I got it right, and then we'll continue on with our problem. So now I have it still, let me change colors. I still have it set equal to 0. And so what I want to do now is go by the property, if a times b is equal to 0, then I can set a equal to 0 or b equal to 0. And so I'm going to do just that. X minus 7 is equal to 0, and x minus 4 is equal to 0. Solve both of these for x. Notice that I'm dealing with a quadratic, and so I'm going to have two solutions. And here they are, x equal positive 7 and x equal positive 4. And that is how we solve a radical equation. But notice we have to remember the second step. We need to check for extraneous solutions. Well, I have my two solutions derived from the original equation, but now I have to go back up to the original equation and plug these in. So I'm just going to grab this original equation, I'm going to bring it down just to make it easier. And so now I can take this x equals 7 and this x equals 4 and plug both of those in 2 separate times. The square root of 7 minus 3 plus 5 equals 7. So I have 7 minus 3 is 4, leaving me with the square root of 4 plus 5 equals 7. The square root of 4 obviously is 2 plus 5 equals 7, giving me a correct true solution at the bottom, 7 equals 7. So what that's telling me is that 7 is a solution. Next, I'm going to bring this equation right over here so I don't have to recopy it. I'm going to plug 4 in and do the same exact thing. From here I have the square root of 4 minus 3, which simplifies down to the square root of 1 plus 5 equal 4. Well, the square root of 1 is 1 plus 5 equal 4, and you're starting to see where the mistake's going to come. 1 plus 5 is 6. 6 does not equal 4. Therefore, 4 is not one of my solutions. So the final solution for this problem or example is x equal positive 7.